Greetings, I'm Caleb Kroll, and I have an interesting paper to share. It's titled, "A Therapeutic Reduction of Ataxin-2 Extends Lifespan and Reduces Pathology in TDP-43 Mice." So here's a little bit of background so you can better follow the results I'll be presenting. ALS is a neurodegenerative disease that destroys motor neurons. There are currently no cures for ALS, which has motivated research into finding cures. One of the pathological features of ALS that has been a focal point of this research is that 97% of ALS cases can be attributed in part to the aggregation of the protein TDP-43. In addition to this, studies in yeast and fly models have shown that decreasing the levels of the protein ataxin-2 can mitigate TDP-43 aggregation. So the purpose of this paper was to see how decreasing the levels of ataxin-2 would both affect TDP-43 aggregation and disease progression due to that aggregation within TDP-43 transgenic mice. The rationale for this is that these transgenic mice are a good model for the progression of ALS, and effective therapies for these mice has the potential as an effective treatment for ALS in humans. So one of these experiments was exploring how the use of antisense oligonucleotides would affect TDP-43 proteinopathy, or disease caused by TDP-43 aggregation. Before I get into those results, let me briefly explain what ASOs are. ASOs are engineered pieces of DNA that can be designed to bind to specific strands of mRNA. Once bound to those mRNA, they can ultimately lead to their degradation, thus preventing their translation. And so in this experiment, they were seeing how ASO therapies could regulate levels of ataxin-2 mRNA and how that would affect disease within these mice. And so the setup of this is that groups of wild-type mice and transgenic mice were given either a control ASO or an ataxin-2 ASO, which binds specifically to the ataxin-2 mRNA. As shown in Figure A, these ASOs were administered into the mice via ICV injections directly into their brains. After administration of these ASOs, disease progression was assessed by monitoring their survival and motor functions, and in addition to this, 3 weeks after administration of the ASOs, levels of ataxin-2 mRNA and TDP-43 mRNA were measured in the mice. The first set of results relate to those mRNA levels. Figure B shows the levels of ataxin-2 mRNA. It shows that those mice given the control ASOs had higher levels of the ataxin-2 mRNA in comparison to those mice given the ataxin-2 ASO. In fact, there is a 77% reduction in those mRNA levels. In Figure C, it shows the levels of TDP-43 mRNA in these mice. As expected, wild-type mice had no TDP-43 mRNA, while both transgenic mice had detectable levels of the TDP-43 mRNA. It should be noted, however, that despite the different therapies, the levels of this mRNA were roughly equal in both groups of those mice. In terms of assessing disease severity, the survival of the transgenic mice was measured, and those results show that the ataxin-2 ASO mice had a 35% increase in their median lifespan compared to the control ASO mice. In terms of motor functions shown in Figure E, that was measured through gait impairment scores, where a lower gait impairment score indicates less impairment, while increasing impairment scores indicates increasing impairment. And so that shows that, again, wild-type mice had no impairment with scores of 0 across the experiment, while both groups of transgenic mice had increasing impairment over the experiment. It should be noted that those mice given the ataxin-2 ASO had a slower rate of increase in their impairment scores, thus leading to lower impairment scores overall compared to those transgenic mice given the control ASO. So what results are provided by this experiment? Well, it shows that in comparison to the control ASO, the ataxin-2 ASO can reduce levels of ataxin-2 mRNA in both wild-type and transgenic mice. In addition, within the transgenic mice, this therapy can both increase their lifespan and improve their motor functions. It should be noted, however, that neither ASO appeared to affect the levels of TDP-43 mRNA in these mice. And so what is the significance of these results in the context of the whole paper? Well, it supports the overall conclusion in this paper that the ataxin-2 mRNA can both increase lifespan and slow down the loss of motor function. So the overall significance of this paper is that it shows that therapies that target ataxin-2 and mitigate TDP-43 proteinopathy have the potential for treatment for ALS and potentially other neurodegenerative diseases. In addition, the use of ASO therapies that we're studying in this paper provides a new precedent for ASO therapies in neurodegenerative diseases, which is to use ASOs to target genes that are not directly causing neurodegenerative diseases, which other researchers can explore further and potentially develop new therapies. Thank you for listening, and I hope you found this both enjoyable and informative.